Hello, before I begin, this video is split into two parts. Part 1 goes over the introduction of the video, the view section, dimensions, edges and line types, and that's where it ends off. In video 2, we'll go over holes and features. Thank you. Welcome to the CSG Engineering Society YouTube CAD video series. In this video, we're going to teach you how to read engineering drawings for the CAD competition. Now, before we continue, I'm going to briefly mention tolerances. It's a big and delicate topic, and so I won't go into too much detail. But tolerances can be applied onto individual dimensions, and they can be applied to normal dimensions like this. And if they don't have it applied, then you can infer it from the block over here, the general tolerance or the global tolerance. Now, why it's so delicate is because this 5 over here and this 5.0 over here are treated differently. Because the 5 over here, based on the general tolerance over here, can be 4.5 to 5.5. Okay, plus or minus 0.5. And this 5.0 over here, it can only be 4.9 to 5.1. Okay, so just that little difference can make the precision of a part change so much. Though you guys won't have to worry, because for the CAD competition, we'll ignore general tolerance, okay? And you'll just need to model parts as you see it. So 7 over here, you'll just enter 7 mil. 3 over here, you'll enter 3 mil. Okay. Now for this video, the coverage will be, we'll first talk about views, and then talk about dimensions, then talk about lines and edges, and then we'll talk about holes and features. Okay. Okay. So orthographic projection. So what is it? It's basically these views that you see over here. Okay, well, this one over here, and this one over here as well. Okay, these 3 views appear at 90 degrees to this view over here. Okay, now the version that we use is third angle projection, and that's denoted over here. This is a projection that mainly America and some parts of the UK use. So what it basically means is, if you want to look at this part, so from your front view, like over here, if you want to look at its right side, then the displayed parts will appear on the right side as well. Okay. So whenever you guys see this sketch over here and this sketch over here, right? What you'll have to imagine is that this face is on the right side of this sketch over here. Okay? And so, this sketch over here, it's the top view of this sketch. So, this is my front view. If I were to look from above, this is from the top view. Okay? This is technically a section view, but it's still a top view. Now, you only need as many views as is needed just to communicate the design, okay? So I felt like 2 was enough. So that's why I only have 2 views over here, okay? But you can have 3 views if you want to. Now, some of you guys may have noticed, but this engineering drawing over here is different to the previous engineering drawing that I used in the other video. Now, why is that? It's because I realized that the circle over here in the other sketch, the depth of it, how far it goes into the material, wasn't fully described. You can't tell. It doesn't describe it, okay? And so for this drawing over here, I've instead shown clearly over here that this hole goes all the way through. Okay? Engineering drawings, like how people say maths is a language, engineering drawing is also a form of a language as well. And so you need to, and so when people make it, they need to clearly explain what's going on. As for you at this stage, you just need to be able to read it. So for you, when you see this, you will then think of, okay, this hole, it goes all the way through. Okay? So this hole goes all the way through. And it cuts out into the open. Dimensions specify location and size. Okay? So for example, if this were to be the origin, let's say, this information over here tells me that the center of this circle is located 5 millimeters away. And then it tells me that the size of the circle is 3 millimeters. So every part has a location and a size as well. And if the location isn't specified, then the other option is that it may be specified through geometry instead. For example, this arc over here hasn't been stated exactly how far away it is from the center. But what it has been told is for it to be tangent to this arc over here and perpendicular to this arc over here. And that's how it knows how to locate itself. So a couple forms of dimensions that we can have. We can have linear dimensions. So stuff like the length of an object, the width of an object, the depth of an object. We can have diameter dimensions. We can have radial dimensions. We can also have angular dimensions as well. Okay, so there's edges and line types, okay? So there's 4 types of lines and edges, okay? Visible lines, hidden lines, center lines, and center marks, okay? So when you have a view, okay, and you're looking at the view head on, any edges that you can see, they appear as solid lines, okay? This arc over here appears as solid. However, something like this hole over here, since it's not visible in this, if you look from this direction, since it's not visible, it appears on the sketch as hidden lines, okay? So if you're reading this, you could infer that, oh, there's probably something behind this layer, and so then you would look through another view to see what it is, and then you spot, oh, it's a hole. It's a threaded hole, like so, okay? So always, whenever you see a hidden edge, you will then cross-reference it with a different edge across, okay? Same for everything, actually. Actually, everything. So let's say this vertex over here, right? You check where this vertex would lie along here, okay? You check where this edge over here aligns here. And the same for everything, okay? So the circle over here, you see if it aligns here, and so on. As for center lines, because circular features are very common, circular features have center lines and center marks, okay? Just to be able to, like, at a glance, be able to tell that they're circular features. So over here, this is a center line, okay? It runs in the middle of the hole. Center line here, and here. They're denoted with these kind of long dashes, short dash pattern, okay? As for hidden lines, they have dashes as well, but they're equally spaced out. So that's the hidden line. This is a center line. Actually, wait, that's not a center line. This is a different line, okay? As for center marks, is these plus looking ones over here. Okay, so if you're looking at a circle head on, you'll always have a center mark just to tell you that this is a circle. Now, for those who were wondering what this section view was over here, let me show you what it looks like in the 3D model itself, okay? So here's your model, okay? And if you were to cut a line straight through the middle, like so, and then you were to look at it from above, this is the way you would see, okay? So let's click back. That's what you see there, okay? The green parts in the image earlier, they're the shaded regions, okay? And the shaded regions, that's where the material was existing, okay? That's where the material was. So you see over here, right? Inside of the circle, because no material is cut, the texture is different, okay? But where the material has been cut or sliced through, we make it obvious that it has been cut by either using hatching lines, or in the 3D models case, is using a green color. Section views are used to display dimensions or dimensions that would have otherwise been hidden edges, okay? So this hidden edge over here, right? It's advised for us to not dimension hidden lines. And so what we will do for you is we will give it to you in a way that the feature is clearly visible, and then we will then give it to you as a dimension. Okay? So you can clearly see, okay, the hole goes through all the way through, and even this hole over here is also a through hole because it enters the material and it exits the material over here and into the open over here.